This is part 3 of the Legacy JavaScript Algorithms and Data Structures course on freeCodeCamp. In this video, we'll be completing steps 12 through 33 of this course. In the first step here, in the first challenge, we're going to actually match what's called white space. So essentially, space characters. In previous challenges, we were matching for specific characters, whether they were letters or numerical characters, numbers. We can actually match white space using the /s syntax. And in this challenge, we want to change the regex count white space to look for multiple white space characters in the string. So here we're going to, in this change line, we're going to add the syntax /s and add the global flag at the end because we're going to match repeating instances of white space, or just repeating spaces essentially. So here we're going to run that, and it works. So in this challenge is essentially the opposite operation to matching white space, which is called a matching of non-white space characters. So here it's similar in syntax to the character class. So instead of using the lowercase s to match white space, we'll be using the uppercase s to match any character that is just not white space, any character. So in this challenge, we're going to change the regex count non-white space to look for any instances of non-white space characters in the string. So it's going to be similar to the last challenge in that we'll be adding the syntax /s here. And again, we'll add the G global flag so that it'll match every instance of non-white space characters. I'm going to test them, and it works. In the next challenge, we're going to match characters in strings that appear a certain number of times in the string. So that's accomplished using the curly brackets syntax, whereby numbers or quantity specifiers are inputted into the curly brackets to specify upper and lower limits of characters that appear in a particular string. With the example being to match the letter A appearing between 3 and 5 times in the string AH. The syntax that would be used to accomplish that is A, curly brackets, 3, 5, and then H, enclosed within the single slashes. So in this challenge, we're going to change the regex regex to match the entire phrase, oh no, but only when the string contains between 3 and 6 H's. So we're going to go into this change line here and put in capital O because it's case sensitive, then lowercase h, and then curly bracket open 3, 6 because we want the letter H to appear between 3 and 6 times in the string to match, that's going to be matched. And then we're going to close the curly bracket. And then we're going to put a space and O, because it's the string O space no. So we're going to run it, and it works. So the next challenge is to actually only specify a lower number of matches in a particular string. And this is essentially accomplished with a very similar notation or syntax with curly brackets, but instead of there being an upper limit or upper quantity specifier, there only will be a space. Right, pardon, not a space, but just a comma and a closed curly bracket. So no space and no number at the end, essentially. So essentially this is telling the function to match strings appearing a minimum of 3 times in this example, telling the function to match the letter A appearing a minimum of 3 times. So in this challenge, we're going to change the regex, ha regex, to match the word huzzah, but only when it has 4 or more z's. So in this change line, we're going to add capital H A Z Z, open curly bracket 4, comma, close curly bracket, because we only want to match a minimum of 4 z's appearing in the string, and then ending with a h. We'll actually only use 1 z for that. And it works. So it'll only be 1 z because we only need a minimum of 4. So we don't need 2 z's to appear in our match string, essentially. We only need 1. 1 z that appears at least 4 times in the string. Hence why this test works. Now, in this challenge, we're going to specify an exact number of matches, and this is accomplished essentially with the curly bracket syntax with only a quantity inside of it with no other syntax. So if we wanted to match the letter A only exactly 3 times, we would only use 3 within curly brackets and nothing else. So here we're going to change this regex, tim regex, to match the word timber. So here we already know what the word is here, the word or the string. And we're only going to focus on matches of timber when it contains 4 letter M's. So we'll type in here T-I-M, open curly bracket, the letter, pardon me, the number 4, close curly bracket, B-E-R, because again, we only want to match instances of the string timber when it only contains the letter M 4 times. Just like in this tim str string 1, 2, 3, 4 M's. So basically, we're telling the function to match this string. Timber with 4 M's. That's what we're telling the function to do in this match line. It works. The next challenge is checking whether a string has all or none of a particular element. And this is done using the question mark notation, or syntax. So here in the example, we're checking that the string rainbow regex contains instances of the letter U. So this is primarily done to check for variations in spelling of particular strings or words. So here, we're going to change the regex, fav regex, to match both the American English favorite and the British English favorite with an U, with a U. So in the change line, we're going to write the word favorite with the American, or actually the British version of the word, because we're checking whether it contains the U or not. So we'll write favorite, the British version of the word, and then after the U, we're simply going to put a question mark after that because we're checking again whether the string contains this U or doesn't contain it. Just like in the example with the word color, it's very similar. It works. Another method of matching strings is by using what's called a positive look ahead in JavaScript. So essentially, this is a syntax in this format, parentheses, question mark equals, where it actually just makes sure that a particular element in the search is there in the string, but it doesn't actually match that particular search. So it's kind of more broadly used to check for things like passwords, which with specific criteria or elements. So in the challenge, we're looking for look-aheads in the password regex string to match passwords that are greater than 5 characters long, so basically at least 6, and have at least 2 consecutive digits. The way we're going to accomplish that is by actually taking this example here in the let check pass line. We have a positive look ahead here. We're actually going to copy this, paste this into the change line for our challenge, and we're going to actually basically modify it to meet the match criteria. The first one is that the passwords have to be greater than 5 characters long. So in this line here, we're going to use the W metadata syntax, and we're going to just use the number 6 inside of the curly brackets because we just want characters that are at least 6 characters long, okay, or more. And then the second positive look ahead, we were going to search for strings that have at least 2 consecutive digits. So this uppercase D for non-digit characters, we're going to change it to a lowercase d for digit characters only, search for. And we're going to include the star for 0 or more of them in the match. Okay. And then after this field, we're going to have the curly brackets W and then the number 2. So basically, in the second test case here, we're telling the function, the test function here, to match strings that are at least 0 or 2 characters, specifically the digit characters. Essentially, that's what this syntax is telling the match function, or the test function, actually. Actually, this W would go here, and then it would be the D. The next step involves for checking for mixed grouping of characters. So here in this example, to match the string penguin or pumpkin, we'd actually start with the capital P followed by the parentheses, ENGU, vertical bar, or operator, UMPK, and then ending in IN because IN is contained at the end of penguin and pumpkin, with the global flag added at the end of this expression here. So essentially, this allows us to match, this test method allows us to match results that contain one of two different strings. So here we're going to check or match strings of Franklin Roosevelt or Eleanor Roosevelt, such that it's case sensitive. And below, the regex, my regex should return true for the string Franklin D. Roosevelt. So here in the let my regex line, we're going to change this to parentheses Franklin D vertical bar or operator Eleanor space after the end parentheses Roosevelt, because both strings contain that. Roosevelt. And in the next line here, we're going to let that result be equal to the myString dot test of the myRegex test string. Or actually my regex dot test of the myString object. And it works. In the next challenge, we're going to actually use what are called capture groups to match reuse or repeating patterns in strings. This is essentially accomplished with the syntax open parentheses /W plus close parentheses. And then we add the syntax /1 to look for basically matches of that same string or word multiple times. So if there are two /1 syntax elements in the match string, it will repeat the word two additional times, totaling 3. Hence, row, right here, being returned in the match function or method. So here we're going to use this capture group method in regex to match a string that only consists of the same number repeated exactly 3 times, separated by single spaces. So we're going to take this syntax here in the example, and in the change line, we're going to actually paste it. And then instead of it being a /W, it would actually be /D to denote a digit test case, because we're only looking for digits or numbers to be returned here. And then we're going to add the caret syntax at the beginning of that test case because we want it to start with a digit. And it'll be repeated 3 times the same digit, so which would require 2 additional temporary variables, /1, and then a second /1. We want it to end with that temporary variable at the end of the return string, so we'll add a $sign at the end. Run it, and it works. The next challenge involves the usage of capture groups to perform match functions using the .replace method with a little bit of a twist. Here, we're using the replace method to return the string, the sky is blue. And what we do to accomplish that is utilizing what are called capture groups in the replacement string with $signs, essentially. So this can be performed in the replace method itself, or it can be performed in separated by 2 different match, search, and replace strings. So here, we're going to write a regex, fix regex, using 3 capture groups that will search for each word in the string 1, 2, 3. So in this fix regex line, we're going to take this existing syntax, because it'll be similar. In the change line, we're going to paste it. And we want it to match 3 different words in the string, which is 1, 2, 3. So here we'll have in parentheses /W, which is any alphanumeric character, regardless of case. We'll add a second one here, separated by a space. Hence you have spaces here between 1 and 2 and 2 and 3. And then we're going to add a second space to reflect that string. Next, we're going to update the replace text variable to replace the string, the match string 1, 2, 3, with the string 3, 2, 1. So this is accomplished with this syntax here. It's similar. So we have $2 and $1, and we're going to precede that string with a $3 followed by a space, so that it'll essentially replace 1, 2, 3 with 3, 2, 1. And this is essentially accomplished using the $sign syntax. And note that the $sign syntax is placed before the number, not at the end, like we have used in other challenges. This type of syntax, the $sign is used at the beginning as a replace method, essentially, or a replacement string. So we're going to run it, and it works. In the final challenge of this video and in the course, we're actually going to use the .replace method, so a search and replace function, to remove white space that appears at the start and end of a string variable. And essentially this is accomplished by using the syntax /s plus to start with this, because we're looking, this is telling the function here to search for a meta character at the beginning of the string, hello, as indicated by the caret syntax, to search for that string in the beginning. And then the plus is used because we want to indicate any repeating instances of this character. So here we have, for our example, we have 3 repeating spaces in the hello world string. Then we're going to use the OR operator with again, /s plus, but this time we'll end that with the $. So we're going to it's going to search for basically the repeating characters at the end of the hello string. And then we're going to tag the G global flag at the end to indicate that the function can search for repeating characters, essentially, in both cases, both test cases. Finally, in the let result line, we're going to perform the hello dot replace function of the search variable ws regex, and then that's going to be replaced after the comma. That's replaced with essentially an empty string, which is just null space essentially. So it's going to what it does is going to remove any instances of this white space here with null space, which just means it will essentially just delete the empty the spaces essentially in the string at the beginning and at the end. And that works. So this concludes the regular expressions course as part of the legacy JavaScript algorithms and data structures course on freeCodeCamp.